So electrode potential and the transition metal. We did the last question 15. So question 16. So it's the whole exercise is about the electrode potential and the transition metals. So we have to complete this. The scandium is there. The element from scandium to zinc belongs to D block. Most of these elements are transition. Complete the electronic configuration for scandium atom, manganese 3 ion and iron 2 ion. So till argon it is same. And then for scandium, like when you check the periodic table, so we have 21. So till argon is there 18. Then what will happen first? They will go to 4s because filling up is in terms of the energy. So first they will fill up the 4s and then 3d1. So this will be the scandium atom. The next one is manganese ion. So first, the first thing what you do, you try to draw for manganese atom, and then you will just convert into ion. How to do this? Like manganese is 25. So first we'll make it 25. So how we'll make 25? We have 2 here, then 3, 4, 5. So this makes, sorry, we have 18 there because argon is 18, 19, 20, 21, 22, 23, 24, 25. Now we have to remove the because we want, this is for atom, manganese atom. Now we have to make for iron. So what we'll do, we'll remove. But when we start removing, we remove the electron from the last shell first, like which is a 4s. So 4s electron will be removed. So now this is a configuration for a manganese ion. So for a transition metal, always write first for atom and then remove the electron from the last shell to make for ion. Like iron is there. So what is the atomic number, which is 26? So we first make complete for 26. Till argon 18 are there. So we have 19, 20, 21, 22, 23, 24, 25, and then 26. Now we have to remove 2 electrons. So how to remove 2 electrons? We will remove electron from the last shell. So from a 4s, the electron will be removed. So this is the configuration for manganese. For iron too. The next is scandium, iron, manganese are D block, but only iron and manganese are transition. Explain the meaning of this term. D block element. So what is the meaning of a D block element? D block element means when electronic configuration is built up in terms of the least energy level first. So the last electron goes into the d orbital, that is called a d block element. So when we fill up the last electron according to energy, and the term transition metal, what is the meaning of a term transition metal? Transition metal means they will form forms at least one ion with a partially filled d orbital or incomplete d orbital. Explain in terms of electronic configuration why iron 2 ions are readily oxidized to iron 3, but manganese 2 are not readily oxidized to manganese 3. So the main reason is the electronic configuration. Like what will happen? There's a paired electron is there, and like electron in the full orbital in the d iron 3 is easily removed due to repulsion. As you can see here, like when we completed the electronic configuration, we completed that 1, 2, it was 26, 3, 4, 5, 6, 7, because 18 is there. So 19, 20, 21, 2, 3, 4, 5, and then 6. So when we remove the electrons are removed from this shell. Now, why iron 2 can easily be converted to iron 3? Because there's a repulsion between the electron, and this electron can easily be removed out. But in case of a manganese, there is no pair of electron when like it is 25. So this is mixed 25. So when the electrons are removed, Mn plus, when Mn plus 2 is there, like this will be Mn plus 2. This is Mn plus 3, but example, if Mn plus 2 was there, it does not have a pair of electrons in the orbital, so it has less repulsion as unpaired electron. But here, pair of electrons, like charges, they repel each other. That's why iron 2 can easily or readily oxidize to iron 3, but manganese 2 cannot be readily oxidized to manganese 2. Explain why iron 2 and iron 3 ions different colored in aqueous. Detailed explanation why transition metal ions are not required. So why the colored compounds are formed? Because what will happen? The energy difference, the splitting of the d orbital cause different wavelengths. It also depends on the ligand which is present. So the splitting of 3D orbital subshell is different with iron 2 and iron 3. So it absorbs different wavelengths or different frequencies. That's why it gives different color. Like when iron 2 is there, and iron 3 is there, the splitting of these orbitals are different. And it also depends on their ligand. It depends on the metal ion and the ligand which is attached. But in this case, why in aqueous solution? So water is there. Water is a ligand here in aqueous solution. So the splitting of the 3D orbital or 3D subshell is different. As a result, they will absorb different frequencies and wavelength to form different colored compounds. Then concentration of a solution of potassium manganate 7 can be found by titration with arsenic 3 oxide. In this reaction, arsenic 3 oxide is oxidized to arsenic 4, and the mole ratio for arsenic 3 oxide to manganese is 5:4. Deduce the final oxidation number of manganese and explain your reasoning. So how it can be done? We have to explain what will the final oxidation number of a manganese. First, we try to make the equation for reaction between arsenic 3 oxide, like when arsenic 3 oxide is there, it will convert. And we have a manganese, because we have to write, the ratio between them is 5:4. So if we write the arsenic equation for that, so if we have 5 molecules of arsenic, and it will form 5 molecules of arsenic 5 oxide. If we write a balance equation, to balance oxygen, first to balance oxygen, we add water. So 15 here and 25. So we need 10. So we add 10 water molecules. To balance hydrogen, we add proton. So 10 multiplied by 2, 20. So we'll have 20 protons. To balance the charge, we add electron. So here the net charge is 0. Here the net charge is plus 20. So it should be 0. So we should add 20 electron. So means 5 arsenic 3 oxide molecule loses 20 electrons. So one molecule, how many electron will lose? So one is losing 4 electron. Then we have MnO4 with a charge -1, because we don't know what oxidation number is there, and the ratio between them is 5:4. So total, what will happen? 4 molecules are gaining 20 electrons, so each molecule will gain 5 electrons. And oxidation number for oxygen is -2, so 4 will be -8, so manganese is +7. So 4 molecules are gaining 20 electrons, so each molecule will gain 5 electrons. So if we have Mn, which is +7, and if it gain 5 electrons, so what will the last oxidation state? So the last oxidation state will be +2. So the final oxidation state will be Mn2 will be there. Because the reasoning is that 5 arsenic loses 20 electron. So it means the 20 electrons, 4 Mn will gain 20 electron. As I mentioned, the ratio between them is 5:4. So when they gain 5 electron, each will gain, when they gain 20 electron, each will gain 5. So when Mn is +7 and each gain 5 electron, so the final oxidation number will be +2. Is it clear, this one? Part B. State what is meant by the bidentate ligand. What is the meaning of a bidentate ligand? Ligand which has 2 atoms that can form a coordinative bond with a metal. So bidentate